Good afternoon, everyone. I hope that you're having a fantastic day so far. Happy Friday, that's always a good feeling. We're looking today at finishing off our work with applications of exponential functions that we started on Wednesday. On Wednesday, we looked at exponential functions in terms of things like population growth, and we also looked at what's called radioactive decay or half-life. Today, we're going to be applying our knowledge of exponential functions to investments, specifically interest. And we're going to be going through 3 examples. It's not a very long lesson, but the details are important. Jerry invests $10,000 into an account that pays interest calculated at 8% per annum. That means that for the whole year, he's going to get 8%. And additionally, it says it's compounded annually. Now, what that means is Jerry, let's just assume that Jerry puts his money in the account on January 1st. If Jerry were to look at his account balance on January 2nd, it would still be $10,000. If he were to look on June 5th of that year, the balance would still be $10,000. In fact, the balance is going to be $10,000 for the whole year, and then on the very last day of the year, the bank is going to calculate 8% of that $10,000, and they're going to add that to the balance. And that's what compounded annually means. It means it's going to be calculated at the end of the year. The question is, how much money is in the account after 14 years? So this is a long-term investment. One of the other things I think that's important to realize is that at the end of the first year, he will have more money in the account than $10,000. It turns out he's going to have $10,800 when that 8% interest is added. At the end of the next year, when they calculate interest, they're going to be calculating 8% of the new balance. And this is why it's exponential growth. What's happening is Jerry's money is being multiplied by something regularly. We are still going to be using the formula that we learned about on Wednesday, which is y, the thing that is growing or declining, equals a multiplied by b to the t over p, where a is the initial amount, and in this particular question, the initial amount of money that Jerry has in the account is $10,000. B is the factor of change, and it's this number that Jerry's money gets multiplied by regularly. And since he's getting 8% at the end of the year, the factor of change is 1.08, which represents 108%. And P is the regular period. In other words, it's how often the factor of change is applied, but it's applied annually. It's applied in Jerry's case every year. So this is 1 year. And from that, we can build a function. Don't forget that y and t are variables. Y represents the amount of money in Jerry's account, and it will be equal to a, which is 10,000, multiplied by b, which is 1.08, raised to the t. Now it's raised to the t over p, but p is 1, so t divided by 1 is just t. And this is the formula that we can use to calculate the amount of money in Jerry's investment at any point in time. Which means if the question says how much is in the account after 14 years, all we have to do is put 14 in for t. And the amount of money will be equal to 10,000 multiplied by 1.08 raised to the 14. That's a pretty basic calculation to throw into the calculator. $10,000 multiplied by 1.08 raised to the 14 gives me $29,371. Money is always rounded to the nearest hundredth. So it's $29,371.94, which means it went from $10,000 to $29,000, and that means that the difference between those two numbers is the amount of interest earned. By the way, interest rates nowadays are nowhere near 8%. There's no way you're going to find something that's going to guarantee 8% per year on an investment. But this is the balance at the end of the 14 years. The other part of the question says, how much interest was earned? Well, if he started off with $10,000 and then it's valued at $29,371, the interest earned will be the difference between those two. Which means that Jerry earned $19,371.94 in interest. All right, that's the first example. Let's take a look now at what Elaine does. Elaine also has come into a boatload of money. All of a sudden she has $10,000. She doesn't know what to do with it, but she's found an account that she can put it in, and it's going to pay interest at 8% per annum. That means 8% per year, but this time it's compounded quarterly. Now, what does that mean? Well, what it means is that she is going to get, for the whole year, 8%. That's what 8% per year means. So if this represents 1 year, she's going to get 8% during that year. But it says that the interest is compounded quarterly. Now what that means is that the bank is going to take this 1 year and they are going to split it into quarters. And they're not going to give her 8% at the end of the year. What they're going to do is give her 2% every quarter of a year. So her money at this point in time is going to be multiplied by 1.02. And then at this point in time is going to be multiplied by 1.02. And at this point in time will be multiplied by 1.02. And also at this point in time. So the 8% is divvied up into 4 pieces. Now how does that change the values of A, B, and P? Well, let's check it out. The value of A is still the initial amount, and just like Jerry, she starts off with $10,000. The factor of change, though, is going to be 1.02 because she gets 2% regularly. See, this is the thing with compound interest. She's getting less of a percent, but she's getting it more often. It's still adding up to what the bank advertises as 8%. Now the period, you have 2 choices here for what you could put for the period. You could put 0.25 years. Or you could put 3 months, because a quarter of a year is 3 months. There's 12 months in a year. If I divide up a full year into quarters, each of those quarters is going to have 3 of those 12 months. You're going to have 3 months and 3 months and 3 months and 3 months. That's 12 months. And that means that you can get for Elaine's investment 2 different formulas. You can get Y equals A, which is 10 grand, multiplied by 1.02 raised to the T over P, T over 0.25, or you can get Y equals 10,000, which is the initial amount, multiplied by 1.02 raised to the T over 3. And they're both correct answers. It's just that the equation on the left has T in years. The equation on the right has t in months. And I'm not going to tell you to use one or the other. Everybody is going to have their own preference. But let's solve the problem now. The problem is, how much money does she have in the account after 14 years? So if I solve it with the equation on the left, I'm going to have 10,000 multiplied by 1.02 raised to the 14 over 0.25. If I solve it with the equation on the right, I have to figure something out first. I have to figure out how many months 14 years is, because the equation on the right has to use months. Well, that's pretty easy to do. I'm just going to take 14 multiplied by 12, and this will be the number of months. So it's 168 months. Which means if you use the equation on the right, you're going to have Elaine's investment will be worth 10,000 multiplied by 1.02 raised to the 168 over 3. And what I would like you to do is grab your calculator right now and figure out what 14 divided by 0.25 is, and then figure out what 168 divided by 3 is. And what you're going to discover is you get 56 no matter what. 14 divided by 0.25 is 56. Which means that Elaine's investment, if you use the equation on the left, will be 10,000 multiplied by 1.02 raised to the 56. And if you use the equation on the right, Elaine's investment will be y equals 10,000 multiplied by 1.02 to the 56. It doesn't matter which way you approach it. The bottom line is that exponent is 56. Because for the 14 years, no matter how you look at it, she will get 2% interest 56 times. That $10,000 is going to be multiplied by 1.02 and 1.02 and 1.02. I'm not going to say it 56 times, but it's going to be multiplied by 1.02 56 times because she gets interest 56 times. So regardless of how we approach the problem in terms of what we use for t, the answer is going to be the following. That at the end of the 14 years, Elaine is going to have $30,311. And I think I saw, and 65 cents. That is the balance at the end of the 14 years. The interest, again, will be the difference between the balance and her original investment. So if I subtract 10,000 from that, I get an interest of $20,311.65. And one of the lessons to be learned here is that that's more interest than Jerry earned. So the more frequently you get interest calculated, even though it's a smaller amount, the better off it is for you because you'll get more money. Now let's take a look at Kramer's investment. Kramer also has $10,000 that he's going to invest, but it's invested at an interest rate that's compounded monthly. So what does that mean? It means that in a whole year, Kramer is going to get 8% for the entire year. This represents 1 year. But it's compounded monthly. Now I'm going to do my best to split this up into 12 pieces. And you can count these off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Kramer's going to get 8% throughout the year, but it's going to be divvied up. And he's going to get only 1/12 of 8% in each period. And I want to write this out. In each compounding period, which is a month, Kramer gets this percent. If I told you that I was going to give you $800, but I was going to break it into 12 equal pieces, you would take that $800 and divide by 12. Well, I'm taking 8% and dividing it by 12. And what this number is in decimal form is 0.666, etc. So he's getting this percentage every month. 0.6 repeating, and that's percent. Now let's just stop for a second. When we had Jerry's investment and he was getting 8%, we didn't take 1 plus 8 to get this number. We took the percentage and divided it by 100 and then added it to 1. When we take a look at Elaine's, we kind of just write down this 1.02 without thinking too much about it, but we got that by taking the 2% and dividing it by 100 and then adding it to the 1. So to go from the percent to the value of B requires you divide the percent by 100 and then add 1. I'm going over this explanation here because with this percent, it's not entirely obvious what B is. B will be 1 plus that percent, 0.6 repeating, over 100. So we have to divide it by 100 first before we can talk about what B is. There's our percent. It's still on my calculator. I'm going to divide it by 100. And then I'm going to add 1. So my B for Kramer is 1.00 and then 6 repeating. And what a lot of people do, and I've had students ask me this before, they look at that and they go, well, that's crazy. That's hardly anything. Yes, it's hardly anything, but look how often Kramer gets this factor applied to his money. It's applied every month. It's not every 3 months. It's not every year. It's every month. That's B. A is still $10,000 for Kramer's investment. P is 1 month. And in this particular case, if it's ever monthly, I would recommend using P equals 1 month. Don't try to convert months to years. It gets too messy with the decimals. This means that Kramer's investment is the initial amount, A, multiplied by B, which is 1.006 repeating, raised to the T over 1. So don't forget in this equation that we've just developed that T is in months. So we need to figure out, to answer the question, how many months 14 years is. We've already done this. If you take 14 years times 12 months per year, it's 168. Which means that Kramer's investment will be equal to 10,000 times 1.006 repeating raised to the 168, and we can throw that into our calculator. and you end up with $30,534, which is the largest balance between Jerry, Elaine, and Kramer. That's the balance. And again, if you wanted to know the amount of interest, you would take the balance and subtract the $10,000 original investment, you get $20,534.84. So that's it today. You're dealing with compound interest. You have to watch out for those words. By the way, there is one type of interest that we didn't look at that you're probably going to encounter, and sometimes you will see the phrase semi-annually. What semi-annually means is you have to take the interest rate and divide by 2 because you're only getting interest twice a year. So monthly means 12 times a year, quarterly means 4 times a year, semi-annually means twice a year, and of course annually means every year. On page 364, question number 10, 11, 13, and 14 deal with compound interest and money investments. And then there is one additional problem below that I would like you to do as well. That's it for today. Have a fantastic weekend, and we'll talk to you soon. Take care.